Hello there. So we got the few questions. So aldol and retro-aldol reaction problems. So first thing I would look at is this question. There's two aldehydes given. So the first, try to note the alpha hydrogens in white. That's going to be the best nucleophile. The other one will be the best electrophile, the carbonyl. So then I can kind of redraw the nucleophile, which is bringing the two hydrogens taken out by the base. So I'm just going to copy the green one, which is you see the alpha hydrogens that will be taken by the base, and the oxygen goes away finally with the heat. So we're going to make that double bond. So make sure that first the double bond, and the yellow skeleton still there, and then the green skeleton, and you can see the removed water molecule actually created the double bond. So this is the end result, alpha beta unsaturated. That's the best way to go by. Even when I see a problem, if I don't see the heat, I'm going to add the heat out of my pocket and go to the alpha beta unsaturated. Then actually you can come back to the middle point. So that's like less complicated. See, try to look at the pattern. In this case, what you have, instead of the double bond, you have the beta-hydroxy compound. You see, that's the beta position. To the green aldehydes, that's the beta-hydroxy, right? That's the product if you don't have heat. Now, you can stop the video and give it a try. Do it slowly. So look at this one, the pattern here. We have acetaldehyde given or ethanol given and base only. Now I'm just going to put the heat and see how to do this. This one nothing else given to me, right? This is a little confusing, but I know the electrophile and the nucleophile the same compound, so I'm just going to draw another one in red and then remove the water molecule and then create the double bond in between the two molecules. That's the important thing, and then copy the rest. Now you have it. You have the alpha beta compared to the red carbonyl, the unsaturated compound, right? Now I can come down to the middle with the beta hydroxy compound. So that's beta hydroxy counted from the red aldehyde, because aldehyde, and then the red carbon is alpha, then the next one is beta. So this is the beta hydroxy compound. So since I was not given the heat, so I will be stopping at the beta hydroxy. If I'm given the base and the heat, I will be going all the way to the alpha beta unsaturated. So that's how you do it when you are given one aldehyde, one ketone with the base. Got it? Okay. Now, so again, the same pattern. So stop the video, look at the question and do it. I didn't copy the wrong answers in this case. I just worked it out. Okay. Now here I'm given benzaldehyde, and then I'm given again it is 2-carbon ethanol, but it's kind of a twisted carbonyl functionality given, right? It's not really clear. So make sure this one is, you just copy as you can see the alpha hydrogens because it's the nucleophile, and then the carbonyl functional I would always draw C double bond O, then remove the water molecule and copy the double bond connected the two pieces, the red and the white, and then you can complete the rest of the skeleton. I usually copy everything in the same direction so you don't, struggle to do it. Now, so I had the heat, I had the base KOH, so therefore the removal of the water is pretty obvious in this case, right? Okay, so the next question, let's see what we have here. Yes, so I have another aromatic benzaldehyde, and then yes, now we have another aldehyde aromatic, right? And in this case, again, the nucleophile would be with more carbon, so ketones are more nucleophilic and the aldehydes are more electrophilic. So my electrophile is benzaldehyde. So remove the water molecule as we planned and put the double bond in the center, the green one first, and then copy the electrophile, and then on top the nucleophile, right? So that's how kind of the shortcut, and then the heat, base and the heat is given. So beta electrophile and the beta nucleophile. So that now we are going one more step just to identify those two. Now also, I just want to throw this one here, retro. If you're going retro, you're given the right side product. you put the water molecule in between the double bond alpha beta, and then across the double bond cut it horizontally, and then you stick the solid blue oxygen and the 2 blue hydrogens onto the nucleophile. Then you have the reactants, right? That's going backward. So this is popular among some of the professors, right? They want to go back. It's much more harder to see. But you want to go forward first and see whether you can go backward. So that's another way. Okay, so let's look at this one. Number 5, I have, this is a retro. So you're given, because how do I know? Because I see the alpha beta unsaturated bond, right? Double bond. So I know this is a retro. So in a retro, heat and the water is added. So that's also confirms it's a retro. Now I put the water molecule across the double bond alpha beta unsaturated and cut through the double bond. Now you have the solid blue oxygen sitting on the double bond, and that's one part separated. And I can just put the numbers 1, 2, 3, 4, 5, 6 just to see where the location. That's a good idea too. And then 3' and 4' for the sort of the hood part. And then 3', 4', 5', that is just there, but we know the 2 blue hydrogen sticks into the 5' carbon. Now it's separated. So that's how you got it. This is the reactant on your right now, because we did the retro-aldol. We basically warm with water, right? Hot water gave you that one. So if you're actually going backward, in this case, actual aldol reaction, you need to have the base, the heat, and removal of the water. How do we remove the water? According to the yellow circle. Look at that one. You take those 2 hydrogens and remove the water, right? Okay, so the last question today, and let's see this one. So you have, again, you're given one ketone and the base and the heat. So we are going all the way. That's the question. Now, I did not copy all the answers. There are wrong answers, 4 of them and 1 answer correct. But here I identify 1 is a nucleophile, 1 is electrophile, 2 alpha hydrogens, oxygen, circle, remove the water molecule, and then put the new bond in the red, double bond, and then stick the other cyclic. You see, that's how you get the answer. So this is the aldol product, alpha beta unsaturated compound, right? So identifying alpha hydrogen and the carbonyl or electrophilic carbon oxygen is the best way to go by. So you can also go backward and try that too. Thanks.